Today in class, we were introduced to negative exponents. And one of the goals was to be able to recognize that negative exponents follow the same identities as positive exponents. So if we're trying to solve or compute, which means, by the way, find a solution. So if we're trying to find a solution to this, we need to remember that when we have the same base, so notice we have -2, -2, -2, -2, so same base, and it's being multiplied each time, we can keep the same base and add all of the exponents. So I'm going to keep -2, which we put in parentheses because negative base needs parentheses. Now let's just start adding all these exponents. So 4 plus 3 plus -2 plus 0 plus -2. All right, so if we do this, we've got 4 plus 3, right, which would be 7. 7 plus -2 is like 7 minus 2, right? So 7 minus 2, which gives me 5. 5 plus 0 is simply 5. And then 5 plus -2 or -2 equals 3. So what I end up with is -2 to the third power, which we know that is -2 times -2 times -2. Now, earlier in the year, we learned that if we have a negative base and an odd exponent, our answer will be odd. And so the computation or the final answer should be -8. Now, there's also problems where we're trying to demonstrate some of these properties. Now, you might look at this and say, well, this is obvious. It's power of a power, right? And therefore, we multiply the exponents. And this is true. But what we're trying to do is demonstrate why that works. So if we're able to use the properties of negative exponents that we learned today, we know that 8.2 to the -3 can be rewritten as 1 over 8.2 to the third power. All right, so we talked about flipping and changing the sign. Well, now I know that this 7 on the outside of the grouping symbols or outside the parentheses has to be applied to each of the ones on the inside. So now what that's going to look like is we're going to have 1 to the 7th power over 8.2 to the 3rd power raised to the 7th power. So what can we do from here? Well, we know that 1 to the 7th power is just going to be 1 times itself 7 times, so that's just going to be 1. And over here we have power raised to a power, so 3 times 7 is 21, so I have 8.2 to the 21st power. Now we can use the properties of exponents we learned today, and I can flip this back up to the numerator and change the sign, and I will have 8.2 to the -21st power, which, as you can see, is the same thing they had here. So that's how we're able to prove that with the power of a power, we can just multiply the exponents, and it does, in fact, still work for negative exponents. Last one is very similar. How can we take the exponent laws that we know about concerning negative exponents and figure out that 6 to the -9th power over 6 to the 3rd power equals 6 to the -12th? Well, you might say, well, that's simple, because when we have the same base and we're dividing, we simply subtract. So -9 minus 3, and that does, in fact, equal 6 to the -12th. Yes, that's very good and shows an understanding of the property, but how can we demonstrate that more fully? Well, remember, I can rewrite this as 6 to the -9th times 1 over 6 to the 3rd. And if I want to write something even further, I know that 6 to the negative ninth can be rewritten as 1 over 6 to the ninth. So remember, our negative exponent properties allows me to take this and write it like that. So 1 over 6 to the ninth times 1 over 6 to the third is where I find myself. Now, I realize that the properties of fractions allow me to multiply numerators and denominators, so I'm going to end up with 1 over 6 to the ninth times 6 to the third. Now I realize that I have the same base, and I'm multiplying, so I can add these exponents. So I have 1 over 6 to the 9 plus 3, which equals 1 over 6 to the 12th power. And as we learned today in class, when I have 1 over 6 to the 12th power, I can flip that up to the numerator, and I can change the sign. So my answer would be 6 to the negative 12th power. And as we notice, that is in fact what we had up here. So we are simply trying to demonstrate that the properties of exponents will indeed work if we use negative numbers. Thank you for watching Mr. Hatton's YouTube channel. Hopefully it helped you.